Yara,
Hi, Celine.
how are you doing? Yes, it's the weekend.
Yeah, but I'm home, so no issues. Going
Right.
well.
Where are you living already?
India.
Yeah, but in India, where especially?
It's Tamil Nadu. It's the southernmost state, uh, almost at the tip of India that you see in the map.
It's on the south.
Down, yeah, on the southern. Yeah.
Right. Nice. So I will put the reminder. Yesterday we were 12, 13, something like this, I guess. Yeah.
Okay.
Um, I don't know how it's a weekend.
Yeah, it's okay. And the session is short too for today, so no issues at all.
Right. Mm, I provide a good link. Yes, it's a good link. We highlight schema translation. I put a pin, like pin the message and
Okay.
notify everyone.
All right.
Usually I'm not doing that too much. Um, but this week, as it's super important, I,
Yeah.
I prefer doing that. All right. Uh,
Where are you now?
sorry?
Where are you now? Are you traveling?
No, I'm in France actually. And
Uh,
until June, because after that I'm going to Serbia,
uh-huh.
Belgrade, Belgrade.
Where? Oh, okay, Belgrade.
Yeah, Belgrade.
Uh, we have totally different pronunciations on opposite direction.
Exactly. Then probably Berlin, and after that Cannes.
Yes.
I remember people said Cannes rather than Cannes
Uh,
or Cannes. How do you pronounce it?
I say Canes, but I don't know if it's the right
Cannes,
pronunciation. Yeah.
Cannes. I think all people living there in Cannes will be like, wow, what is the pronunciation?
They're gonna be shocked. Please don't kill our city with pronunciation.
And you know that whole grocery shop like commerçant
Yeah.
players right now in Cannes are accepting crypto.
Oh,
So that's pretty
nice.
cool, yeah. You don't have to spend fiat.
Cool.
All right. I think let's start.
Okay.
And then people will join in 5 minutes, I guess. Like actually, three people are there. That's nice. Always the same.
Hello, everyone.
Nice. Let's go.
Okay. Hi. Let me just start. Okay.
Oh, in India, you
So,
put a lot. Like some points when you talk, like you word something, you put some points after, for
as
example, hello, point.
uh, I'm not sure what you're referring to. Is it highlighting or something?
No, it's like two uh Comma?
No, no, that's not common.
Okay, because when I talk with some indie, every time I s- I have these things.
See that? Oh, okay.
Most of the
Maybe.
time. All right,
Yeah, maybe I didn't notice.
that's good.
So we are here with our contracts of FundMe. Okay, a quick reminder: we are having a FundMe contract, which is used by, for example, creators. Anybody can send money to the contract through this fund function, and they must send a minimum of 5 USD worth of ETH. Otherwise, the contract would not accept it. That's the app we are building. And also, the creator would be the owner of the contract. And since they own it, they should be able to withdraw whatever earnings they get from the contract. So for that, we have the withdraw function here. So we saw until this point yesterday. Today, it's all going to be optimizing our contracts for mostly gas efficiency. So first, let's go over with immutables. Okay. So constants and immutables. You see, there are certain variables in our contract. So we have address public I owner, and we also have minimum USD. If you actually notice, minimum USD is a constant, and owner is we haven't changed it, but it is going to be immutable. Both are state variables, but we also include another keyword in here as constant and immutable. So, what is a constant? Like the word says, it means the value of that particular variable is not going to change. So, when you actually start writing the contracts and you already know that certain values will never change, you are like 100% fixated that it should not change and you do not anticipate it to change at all, then you can put it as a constant. That is what I would say as during compile time. That is, you write your contract, and before you compile, at the time of compilation itself, you already know the value that you need, a fixated value. So in that case, you can put it as a constant. Now, why we do it is simply because when you don't have a constant, and let's say you don't have a constant here, and minimum USD is not set in here like this. So then at some point, for example, within a function or something, you're going to have to insert a value for this. You're going to declare, hey, this minimum, before here you're using minimum USD. So before this point, you would actually set a value of minimum USD here. But that's like a double work. If we already know it, why do we want to include it at a later point? And if we also know that we are not going to change it, we might as well put it as a state variable in here. And with the keyword as constant. In simple, that is what a constant does. Now, there's a very slight difference between constant and immutable. Both are not going, when you know a certain value is not going to change, you either choose constant or immutable. Constant, you do it when you know it at the compile time itself. Immutable, you do it at the runtime. So what do we mean by runtime in this reference? When you actually are done with the contract, you have compiled it, and then after you compile it, you go here and start deploying the contract. So at this point, only at this point, if you know some kind of data, for example, only what are we doing in this constructor here? We are setting that message.sender is the owner. So what is message.sender? Whoever is deploying the contract. So ideally, this contract will know who is deploying the contract only when they deploy the contract. So when there are special cases like this, you actually put them as an immutable variable. How you get the value of the variable that you want, and you save it within an immutable variable in here, like this. So immutable is also constant. You cannot change it after you set. Usually when there is other variables, for example in funders, remember that we also reset our array when we were withdrawing. Such things cannot happen. Both cannot be changed, but constant is when you already know it while you write your contracts during compilation. And immutable is when you know that when you come to know certain values only when you start running or deploying the contracts. So you can get the data from the constructor when they deploy it, and then you can save it once. This so when we already know that constructor runs only once, right? So whatever value you set within this constructor will get assigned only once. It will get saved here, and after that it will not change. That's the only time you'll be able to actually write over it. So in short, that is the difference between them. And here's an example. Okay, so if you already know a fixed value, you just set it up. If you don't know, you don't have a constant at all in the first place. So since we have a fixated value, we have 100. But for example, why think about the scenarios when you choose to have immutable. uh, One is owner. Second, any kind of data that you would come to know when they deploy. For example, the message.value or the message.sender or anything related to that. For example, if we have a variable of int 256, the first transaction value. Okay, if you have something like that, the first transaction value would be what came into the constructor, and you can put it as immutable, and it would get saved within this. Okay, this is messing up the structure, so I'll just remove it. So yes, that is the only difference. In our case, while we actually were writing the contract itself, we needed minimum USD, and we already knew that we if you should at least send me 5 USD worth of ETH. That's why we already declare it as a constant in here. The owner is known only when they deploy it. So we are actually putting it them as a immutable variable. But there is, there are special cases uh, where you can also insert immutable directly when, let's say, let's go ahead with this. When you actually write your contract itself, you can use it. Actually, it's a very useful gas saving technique. Immutable is slightly more gas saving than constant. So a lot of times, instead of using constant, we also choose immutable. And uh, but you have to be careful that you can change your constant to immutable. But if you change your immutable to constant, then uh, that actually does not make sense, because how would you get a value from runtime when you don't know at a compile time? So yeah. And then, okay, why do we use them? It's mostly to save gas and prevent any accidental changes. For example, in here, we don't want anybody else to be declared as owner. Let's say I put this value as, hey, this person is the owner, and this one was not even there. I have compiled the contracts, I have deployed it, but later I come to realize that there is just a slight mistake in it and I forgot to include another digit. So that's going to cause a lot of problems. So it's uh, it's a good practice to get your immutable variables from your constructor and then move it to there. Let's remove them. Okay. Can constant be set in a constructor? No, because we should know it before we compile itself. So that's not okay. And can immutable be updated after deployment? No. Only once when it is deployed, you can write or assign a value to this immutable variable. After that, you can never change. It's almost like a constant. That was it. This is one of the gas saving techniques where you can actually, put as immutable and constant for things that don't change. Next is errors. Okay, why do we have errors? Let's first think in that sense. When someone calls a function and they let's say I am calling this withdraw function and just like, hey, that okay, that is a function withdraw, let me see what happens, and I go and call this withdraw function, but I'm not the owner. I don't know the privileges or what happens within the code. I'm just an outsider. I'm just trying things out and seeing if I call any of the functions, am I going to get some money? So I'm like, very playful and I'm trying it. So when I click this withdraw and nothing, I am sorry. When I click this withdraw and nothing happens, so how would I know that why my transaction failed? If let's take a require statement. Let's bring this back. So in here, uh, hold on. Sorry, guys. Okay. In here, if I call the withdraw function, but I'm not the owner, then in that case, it is returning something called not owner. If I call it as a require, the require will return as, hey, you are not the owner. But if those messages and checks are not given explicitly, then the person who is calling it would not know why the transaction failed at all. That is why we explicitly state, hey, this is the error. This is why your transaction reverted. It's like giving them more context of where it failed. That's it. So for this, there are two ways to do it. One is using require statements, which we saw earlier yesterday when we had require a certain condition. You check if the condition is met. If the condition is not met, then you revert the transaction. If is very, very similar to it. The syntax alone changes. When you want to use custom errors, you first declare the name of the error. For our case, we have within our modifier we are checking, is the person who is calling the calling the function the owner or not. That is the condition we are checking in here. So first, if you have to use custom errors for this, you first you know uh, declare the error in the first place. You first put error not owner. You're just saying, hey, I'm creating a new type of error. This error is only specific to my contract and it is not used anywhere else in Solidity. It's just for the context of my contracts. So you're first giving the context and that hey, this is the error and this is the name of the error that I will be using. After that, you can come up anywhere and keep using the same error. So if in our case we are using it as, if check this condition, if the condition is not met, then you can revert the transaction. It's same like require, but you are having it within an if statement, and you are reverting it as a custom made error that's just specific to your own contract. Let's look at the syntax even further. So here you have a, you you do not specify the errors within your function. You should always specify them within your contract, or before your contract itself. Uh, that's syntactically correct. So you can't put, if you're using an error, you can't just put it in here. You have to already declare it and then use that. So in our case, it is if. If is the keyword. You check the condition. You check if message.sender is not equal to owner, and then you revert. And you revert with the error name, exactly the same error name that you declared. Now, with custom errors, there's one more advantage. That is, you can actually also return a certain value. Uh, Return as in, not in the context of Solidity, but in here you give or showcase a specific values. I can show you an example here. So message.sender is not equal to owner. Okay, so then you revert unauthorized, and you can put it as, this is the value I received. So you can have it as address. That's it. Address is fine. So you can just mention that this is the address I received, and that address is unauthorized. And questions on it. Why use custom errors instead of strings with reverts? This is mainly because in Solidity, strings are stored in bytes, and in general, strings are very expensive to store in a blockchain. Even when you have it as in any formats, in byte 32 or any type of arrays, you are going to be paying a very huge amount, because each of them take up a separate slot. So even if you have a little bit of longer string, sometimes it's going to take a 2x or even 3x the gas fees you would pay for for the normal transaction. So that is why at most we avoid using strings. And but in require statements we had to use, because we had to give context to whoever is sending the transaction. But with custom errors we just simplified it, because this is not stored as a string. It is like it is a separate data structure that is storing just the name of the errors. So it has nothing to do with strings. That and it's also good practice usually to, you know, prefix the contract name before your error. Now we are actually working with only one contract, but when you have multiple contracts, and let's say there is also another contract that has not owner, then it might be slightly confusing even for you to find out, hey, where did this error come from? I'm not even able to identify the contract. So it's a good practice to actually prefix it with the contract name, so that it's just easier for identification. This is another technique to save gas, because strings are expensive. That's the main reason. So what happens when an error occurs? Same thing that would happen with your require statement. It just reverts, and any state changes that happen until that point, it will be it will get how do you say, rewind and undone, and the transaction will revert. That's it. Okay, so custom errors was not always there. It was introduced only after Solidity version 0.8.4. So right now we are in the version 0.8.18. So we can use it. That's not a problem at all. Why is it important to know these versions is now you're learning to develop with Solidity smart contracts. At some point, you would progress to also auditing it. So when someone brings you a contract, it's not necessary that they will give you contracts with the latest version. They might have started development earlier, so they may have been using a different version of Solidity. So it's important to know when features came and have a timeline of it, so you know when if correct syntax was used or correct variables was used, or if there was security issues in certain versions, then you have to know it. That's why. Otherwise you don't have to think too much about it if you're just sticking to development, because after 0.8.4 all of the versions carry on the same pattern. They all support custom errors. Next, so this is pretty important. We have fallback and receive functions. Okay, so what are fallback and receive? Remember constructor. Constructor is also a function, but it is quite different. We don't have function and we don't give a function name, and it gets executed only once. This is a feature specific to constructor. We call it a special function. Similarly, there are two other special functions, that is receive and fallback. Let's get into what each of them does. So when there is a contract and there are so many functions within it, but let's say I am for all these contracts there is an address. You can attempt to send a transaction directly to this address, just like how you would send ETH to any other person. How do you send it? You just copy their address, paste it in there, send your transaction of how much ever amount you want. Similarly, you can also do it for contracts as well. But when you send this transaction, it will only accept any ETH if it has a receive function. Uh, Let me make it clear. If you this is a contract, and if you call the fund function with some ETH value, then it will go through. But if you simply send a transaction directly to this contract with some ETH, then it will only get accepted if it has a receive function. Okay. Why does this happen? Because somebody may have mistakenly sent, or somebody may be trying to exploit something. Let's not go too much into why they do it, but you must understand that all contracts are having the ability to accept ether directly without calling the specific functions. For example, you should not assume that since only fund is here, people would only call fund. No, they may call any payable function with amount, or they may directly send ether to the address as well. They may attempt to send it. So if you want to actually receive the ether, then you should have receive function. So this is only specific to ether. If someone sends an ERC20 token, it is not going to accept. Those are all very specifics, but ether is the native currency, so all contracts by default must accept it. That's why we have this receive function. And fallback is also a special function. How is it different from receive is when so fallback happens when someone calls any of these functions with by mistake, if they try to send ETH to the contract by calling a function that does not accept Ether. That is one case. Let's say someone is calling a withdraw function, but they are, let's say, this is not payable, and they are calling this function with some ETH value. In that case, the Solidity does not know what it has to do. That is why we have something called fallback to accept any mistakenly called functions, you can say. So how does it actually look like? Um, in a let's briefly go over. Okay, we have call data here. Okay, when someone simply sends receive, how would they send? It would just be like, in here I'm just sending from my account, and I'm directly putting in some value. For example, uh, I'm not actually calling any specific function. I'm just directly trying to send a value to this contract. Okay, it is getting reverted. Why? Missing revert data transaction invocation is done. Okay, gas estimation failed. Do you want to force sending? No, I don't want to force send it. So our receive, hold on, let me just check. Okay, it's not enough. Okay, I'm running out of gas. We can't go ahead with the transaction. Okay, so let me just explain it just with this. So call data is where you usually insert what function you want to call. If you want to call withdraw, then let's say it is 0x002, but I am calling it as 0x005. So what Solidity does is it takes this call data and it goes to every function and checks, hey, does this call data match with you? Okay, it doesn't. Then it goes to next function and it sees, hey, does this call data match with this function? I'm trying to, it will be like, there's a transaction incoming and it's having this specific name, but that name is not matching with any function name. What should I do? Then Solidity is going to be so confused. In that case, it is going to call this fallback function. So there are two conditions. So both receive and fallback should be external and it should be payable. We already know what is external. External is that function can only be called by someone outside uh, of this contract. It can be another person or another contract as well. And what is payable? Payable just is a modifier that signifies that, hey, this function will accept any amount of ETH. And it is mandatory to have these special functions with external and payable modifiers. And in our case, let's look at why do we have fund. In here there is receive. If someone is sending you, they didn't call it directly via the fund function. They are simply sending a transaction. They are like so excited, hey, okay, this creator's contract is this, let me just directly send it. If they are like that, what you want to do, you for them it does not make a difference. For you, you actually want to keep track of who all sent you ETH, or who all contributed to the growth. So what do you any so how does this work is, if if someone sends a transaction with ETH, this receive gets executed. So if you put fund within this, then it will receive the ETH and it will call this function with that ETH. So what happens in fund? In fund, it is checking the conversion rate, and it is adding the value to the balance of this contract. That is what is our intention itself. Essentially, we are just making it all a straightforward process instead of having a separate funders array where everyone is calibrated of who sent how much. But if someone randomly sends you ETH, you don't want them to left out. You want them also to be added here in our case. That is why we include fund. And the same goes with fallback. You don't want someone to call a wrong function, or someone who doesn't send call data. So that's why you also reroute that ETH to the fund function. And did we cover everything? Yes. It okay, what is this data? This data is nothing but whatever comes up in here. The call data is what the data is referring to. So in this call data, usually the function signature will be available. Each function has its own signature that is uniquely identifiable. We learned this in ABI, but in simple, you can remember it as a very unique identification for each function will be there. So that is the data we are talking about. So if it is without data, then it will go through receive. But if the transaction comes with data, then it will go through fallback. This is the simplified version of it. Any questions, team?
My ma replied to a few questions.
Okay.
Was there?
Can we somehow stop the deploy contract from being executed? If there is, yeah.
Yeah.
Okay. Good work, Mahima. That was accurate.
Probably you know already each other, no? You and Maima.
We actually were in one call, I guess. Uh, but I do remember you mentioning her. She joined DevBack, and then she became an ambassador, right?
She was an ambassador recently, like
Yeah, with Cypress.
more
Yeah.
than 1 month or 2 months from Cyprus. Yeah,
Uh,
I joined in April. All right,
Nice to meet you.
that's nice. So Hima is also an ambassador from Cyprus.
And if you have any doubts in this and if you need more clarification, please get back to me. I'll reply on Telegram or on X.
All right. So for Cyprin, the courses, uh, try to do it before our community course that's gonna be in 29. Yes. So you have like around 10 days, more than 10 days to complete Cyprin. So take your time, and as we mentioned yesterday, it's like a way to first going through, and then you can come back to whole recording session provided by our amazing mentors, um, with some more explanation about it. And yeah, thanks again, Emma, for everything. You are really clear with everything, so thank you for that.
Fine. Please do ping me if you are stuck at any point or if you get errors. I'll be happy to review it.
Yeah, and by the way, congrats everyone, because uh, some people are participating to the base hackathon. Uh,
Oh,
yeah,
okay.
like around 20 people.
Nice. I think it ended today, right? Today or
Yes, it was
yesterday.
yesterday, and so we
Ah,
got around 13 or 14 application, like
oh,
project submission.
nice.
Yeah,
Nice.
congrats, because it's like this. You're gonna get your first satisfaction, and also is also about taking some methods first. It's also super important to deal with hackathon on the long term perspective. So congrats everyone, and yeah, See you next week. So just for your information, on Monday we're gonna launch application for joining the fellowship program, so Dev2Pack. So you're gonna have like an email about it, and normally a special referral code included your name. So you can use it to invite your friends. All right, all good.
Bye.
Bye bye. Thank you.